Talk about formula mass. So when you calculate the formula mass of covalent and ionic substances, this is actually done the same way. There is no real difference in the calculation per se. The terminology that you use might be slightly different. Formula mass is a term that's used as an all-encompassing term for both covalent and ionic substances. However, you can call the formula mass molecular mass if you're referring specifically to covalent substances only. That doesn't really hold true for ionic substances since they're not considered molecular or covalent compounds. So let's practice calculating the formula mass or molecular mass for a covalent substance. The particular substance we're going to try first is CH4, and the process that you go through is determine all of the different types of atoms in this compound. So carbon and hydrogen are your two different kinds of elements. And then you want to determine from the periodic table what their atomic mass unit, average atomic mass unit would be for each element. So for carbon, that's 12.01 AMUs, and for hydrogen, that's 1.01. I want you to all note that I am rounding all average atomic mass units from the periodic table to the second decimal place, and I would like for you to practice that also. And then what I'm going to do for each element is I'm going to multiply that AMU value times the amount of atoms of that element in the substance. So when there is no number present subscripted behind an element symbol, we assume that that is a 1 for that atom. And here behind hydrogen there is a 4, so we'll multiply that times 4. For carbon, that ends up being a total of 12.01 AMUs, and for hydrogen, that's a total of 4.04 AMUs. And we will add these two total AMU values up, and that ends up being 16.05 AMUs. This value here is the formula mass or molecular mass of CH4. So for ionic substances, again, it works the same way. We're going to write down each element type that is in the substance itself. We determine their average atomic mass unit from the periodic table. For calcium, this is 40.08 AMUs. For chlorine, this is 35.45 AMUs. And we will multiply each times the total number of each of those types of atoms in the compound. So for calcium, there is only 1. For chlorine, there are 2. And we will tally our total AMUs over here. So 40.08 still for calcium. And then for chlorine, it ends up being 70.90 AMUs. When we add these values together, we get a total of 110.98 AMUs, which ends up being the formula mass for calcium chloride. What we're going to do here at this point is I'm going to go through a few examples. Again, just some more practice problems of this formula mass calculation. At the end of this, you should have a fairly good grasp of being able to calculate formula mass. Okay, so let's try this practice problem here of this covalent compound that is made of a lot of carbons, hydrogens, and oxygens. So we're going to go through the same process we have before. We have carbons, hydrogens, and oxygens, and we're going to write down each average atomic mass unit for each element type. So for carbon, that's 12.01 AMUs. For hydrogen, 1.01 AMUs. And for oxygen, when we round to the second decimal place from the periodic table, we get a value of 16.00 AMUs. We're going to multiply each one of these times the total number of that particular element in the substance. So there are 12 carbons, 10 hydrogens, and 6 oxygens. So, keeping in mind significant figures, I know you guys are going to get tired of that. There are 4 significant figures in the average AMU that we have written here. So we do have to maintain that in our total calculation for all of the carbon atom total AMU values. So for this, we're going to write 144.1 AMUs. And this will, you're just going to have to round that to 4 significant figures from the value you get on your calculator. For 1.01, this is 3 significant figures. So when we multiply that times 10, we're going to round that to 3 sig figs, and that would be 10.1 AMUs. And for oxygen, there's still 4 sig figs. When we multiply that times 6, we will get 96.00 AMUs. And we were going to add all of these together. And when we do that, we will get 250.20 AMUs. But we need to look at, when we're adding these together, the least significant digit furthest to the left, and that's going to be on the tens place. It's a little off scale there. So we can only report as far as the 2. We'll use the 0 to round the 2 or not. In this case, it'll be not. And so we'll end up with an answer of 250.2 AMUs for the formula mass or molecular mass of C12H10O6. Okay, another problem. So this particular formula is Ca parentheses NO3 parentheses 2. And the name of this substance is calcium nitrate. And this is going to be an ionic compound because we have a metal and nonmetal. But calculating the formula mass is still the same as we've done with covalent compounds before. So we write each element type, calciums, there are nitrogens and oxygens in this substance. Let's look at the periodic table and figure out their average atomic mass. Calcium, we've seen before, is 40.08 AMUs. Nitrogen rounds to 14.01 on the second decimal place. And then oxygen, again, is 16.00 AMUs. Now we want to multiply by the total number of atoms of each. Calcium is 1. And since you have this parentheses here and a subscripted number outside of that parentheses, essentially what you do is you take that number and multiply times the subscript that is inside the parentheses behind each element. So if it's 1 behind nitrogen, 1 times 2 tells you a total of 2. So we have 2 nitrogens. And for oxygen, it is 2 times 3. That's a total of 6. So our total calcium atomic mass units sums up to be 40.08 AMUs. For nitrogen, that sums up to being 28.02 AMUs. And then for oxygen, 96.00 AMUs. And notice that I'm still maintaining the number of significant figures of our original atomic mass units. We're going to sum all of these together, and we get a value of 164.10 AMUs. And this is the formula mass for calcium nitrate. All right, let's try one more. And this problem, it's a little different in the sense that I wanted to give you a substance, not in a chemical formula, but I wanted to give it to you in the form of a structural formula. And when you're given a structural formula, to find its formula mass, all you do is just count the number of each element that is in that particular structure and just write the chemical formula down. So for us, we're going to write carbon. There are 2 of those, so we'll put a subscript 2, and the only other elements present is hydrogen, and there's 1, 2, 3, 4. So we'll put a 4 here. So to calculate this, we'll have carbon and hydrogen. Average atomic mass unit is 12.01 for carbon. For hydrogen, it is 1.01. And we multiply each times their subscripted number in the formula. So this is 2 carbons and 4 hydrogens. Those sum up to be 24.02 AMUs and 4.04 AMUs. We add all of these together, and that ends up being 28.06 AMUs. And that is the formula mass, or you can even call that the molecular mass, considering this is a particular type of covalent compound. Okay, so those are, I think, 5 total examples of how to calculate formula mass. My recommendation is you guys find some more example problems and just practice going through calculating formula mass, so that this is something that will just be super simple and old hat to you guys for using for other calculations later on in the semester.